All right, we're gonna factor different examples of quadratics. So the first one that we're gonna do is GCF factoring. So GCF factoring, you'll always start with. Always begin with this. So let me give you this equation, and you can write it down on your paper. Pause it, see if you can do it. So if we have 3x squared plus 6x, write that down. So before you begin any problem, like I said, and it says factor, always start with GCF, greatest common factor. So first off, factor basically means to break a polynomial into its multiplication. So if I had the number, let's say 12, I could factor it by saying 3 times 4. Those are two of the factors. Another way I could factor is 1 times 12, 2 times 6. So these are all factors of 12, right? So now that we have something a little bit more complex, and with letters, we're just breaking it up into a multiplication problem, okay? So GCF means find the greatest common things that multiply to create it, right? So we're going to look at each term individually. Right here we have 3, which is just 1 times 3, and then x squared is x times x, and then 6 is 2 times 3, and then x. So we look at those and we see, okay, the greatest things I have there are 3 times x, and we're creating a multiplication, right? That's what factoring means, the multiplication of this. So I got to now think, what did I multiply 3x by to get 3x squared? Well, x. And what did I multiply 3x by to get 6x? Well, 2, right? And the answers are kind of right there. All right, so let's do another GCF real quick. Let me erase that so that we have room to see it. So I'll give you one, you try it, see how you do. There we go. All right, so try this one. If we have 12x squared plus 8x. Go ahead and try that one. Right, so the GCF, we think what multiplies to give us 12, what multiplies to give us 8. Well, there's lots of things that multiply to give us 12, lots of things that multiply to give us 8. So I really focus on the smaller of the numbers. And I think, all right, I have 1 times 8, I have 2 times 4. Does 8 multiply to create 12? Nope. And then the next biggest number is 4. Does 4 multiply to create 12? Yes. So I know I have the greatest between the two because 8 didn't go and the next biggest number is 4. Then I look at their variables. They both have at least 1. So you find the least amount that each has. This one only has 1, that one has 2, the least amount is 1. Then we think, all right, what would 4 multiply to give us 12? 3. What x multiply to give us x squared? And we're done. Okay, so that's GCF factoring. Make sure you know how to do that. And all right, the next one we're going to look at is, so you'll always do GCF. So I'm going to do ones that don't have any more GCF, but remember, whenever you get to a problem, always do that first. Okay, the next thing that we're going to look at is when our a is 1. Okay, so what do I mean by a? Well, every polynomial has a coefficient in front of the x squared, a coefficient in front of the x, and then a constant. So a is the number in front of x squared, b is the number in front of x, c is the constant out at the end. So here my a is 1, my b is 9, and my c is 20. So whenever your a is 1, there's a quick trick you can do. And this is how I set up the trick. I draw an x because x reminds me multiply, and then I start with the c. And I say, all right, got to figure out what multiplies, because x reminds me of multiply, right? Here's my x that reminds me of multiply. What multiplies to give me 20? But then I kind of look, I tilt my head to the right, and I kind of see a plus sign, right? So what multiplies to give me 20, but what adds to give me 9? So that helps me just remember. Multiplies to give me 20. Multiplies to give me 20, adds to give me 9. We're always thinking what multiplies to give us that constant at the end and what adds to give us the b term. All right, so, and then, like I said, this x just helps me remember. Multiply, add. Okay, so I'm going to think. I have 1 times 20. I have 2 times 10. I have 4 times 5. So 1 plus 20 is 21. 12. 9. Got it. It's a 4 and a 5. Okay? So x squared is x times x. 4, 5. And they're both positive, so I'm done. Okay? Now, I'm done. I factored it. I created a multiplication problem for x squared plus 9x plus 20. Now, watch this though real quick. If I wanted to double check my work, I could. And as you notice, something kind of cool happens. I mean, that x squared we knew was x times x. And the 20 we knew was 4 times 5. So why did we have to add to get 9? Well, notice, now that I finished this problem, 4x plus 5x gives me 9x. So that's why we have to figure what adds to give us the middle term. Okay? All right, so let's look at another one. So let's say that you have x squared, let's do minus 4x minus, sorry, thinking real quick, 12. Let's do that one. All right, so I suggest you pause this, try it, see if you can factor that, find its multiplication. All right, so the first thing I do, I notice what numbers I have in front of the x squared and the x. So my a is 1, my b is -4, my c is -12. Okay, so then I remember, oh yeah, my a is 1. Yeah, I got to use the shortcut. So I think, what multiplies to give me -12, but what adds to give me -4? Okay, so I think, okay, I have -1 times 12, but that adds up to give me 11. But that does multiply to give me -12, so I'm good. Then I have -2 times 6, which gives me +4. That looks interesting, right? So what if I try 2 times a -6? Yep, get a -4. All right, so remember, it's these numbers that I use, the ones that multiply to give me -12, but add to give me -4, and those numbers simply go +2, -6 there, and we created the multiplication problem for that guy. All right, uno más, one more. Let's do x, let's do, why am I putting in parentheses? We're factoring. All right, x squared plus 10x minus 11. Go for it, give it a shot. My a is 1, so I'm like, I'm ready to go, right? Okay, a is 1, b is 10, c is -11. Okay, I'm thinking, what multiplies to give me -11? Adds to give me 10. Well, not too many things multiply to give me 11. So I have 1 and 11, but those multiply to give me +11, so I know 1 needs to be negative. Probably going to be this one. Yep. 11 minus 1 is +10, which was my goal. So I have x minus 1, x plus 10, done and done. All right. Okay, we're not quite done yet. So that is if our a is 1. If our a is not 1, we're going to have the similar beginning, but the ending gets a little bit different, okay? So you might remember this from your past class. If you don't and you need more help, please email me, and I will get you more help, okay? So this should just be a review, but if it's not and you're like, man, I don't know how to do this, please let me know. Okay, the next thing that we're going to look at is, so what if, sorry, grabbing my paper that had the problems. What if our a is not 1? So let's say that we had 2x squared. Sorry, I forgot my paper. I'm walking around in my classroom, talking to you. Okay, what if we had 2x squared plus 5x plus 2, for example? Okay, so first, notice your a is 1, your b is 5, your c is 2. Our A is not 1, sorry. Our A is 2. Okay, so whenever this happens, you have to remember, if you remember on a previous example, when I multiplied stuff together, right, the first term always multiplies, the last term always multiplies, and the middle term was formed by addition. So hopefully you remember that. So you know that this one right here and this one are always formed by multiplication, and this one right here is formed by the addition of the like terms. Okay, so just kind of remember that. Okay, so what we're going to do, because A and C deal with multiplication, we're going to do A times C. And in this case, we're going to get 4, because 2 times 2 is 4. So instead of just using C, because A is not 1, we have to use A and C. Now, like I said, some of the steps are still the same, so that 4 will go there, and the 5 will go down there. And then we just got to think what multiplies to give us 4, but adds to give us 5. It's 1 and 4. Okay? All right, so what do we do with that? Well, we're going to write 2x squared plus 1x plus 4x plus 2. And we're going to double check that we actually still have the exact same thing. 2x squared, 1x plus 4x is 5x plus 2. We do. We're doing good. All right. Okay. And now we're going to do this weird thing. Now that we have 4 terms, we're going to break it up into 2 parts. We're just going to factor each part, the GCF factoring that we already just practiced. So I'm going to look right here. 2 and 1 don't really have anything in common, but x and x do. So I'm going to pull out an x, and I'm left with 2x plus 1, okay? Then I'm going to look at the next group. I have 4 and a 2, and I brought down that plus sign, okay? So whatever's in between the 2 groups, you bring it down. 4 and 2, I can pull a 2 out of there, and if I pull a 2 out of 2, I'm just left with 1, okay? Now look here, look here. I'm going to do GCF factoring again. They both have 2x plus 1. So if I pull that out, what am I left with? X plus 2. Nice. And I just factored that guy, okay? So this is the final answer. Now let me show you. I'm going to multiply it to show you where all those things came from. Okay, so when I multiply this, I'm going to do 2x times x, and I'm going to get 2x squared. Then I'm going to do 2x times 2, and I'm going to get 4x. Then I'm going to get 1 times x, and I'm going to get x. And then I'm going to do 1 times 2, and I'm going to get 2. Then I'm going to combine like terms in the middle. Remember, I had a 1 there, but 4 plus 1 is 5. Now kind of look at everything that just happened, right? So I started with this, and then I thought, okay, these guys were formed by multiplication, and for multiply, this guy right here is formed by adding the like terms, okay? So that's why I did A times C, 2 times 2, and I got that 4, and then I thought, what adds to give me 5, okay? Then I broke up the middle with those terms, and then I pulled out, I factored by grouping, right? So basically, factoring is undoing the multiplication, and we just got to kind of memorize those steps to do it. All right, let's look at another one. Let me erase this real quick, and I'll give us one in 1 second. Okay. Okay, that's enough, right? Okay, let me find the problem that I was going to give you guys. All right, so let's say that we had (3x squared). Oh, sorry, not writing. We have 3x squared minus x minus 2. Okay, try that one. Pause this, give it a go. All right, so remember the first step is you're going to take your a times your c, because those were both formed by multiplication. And we get -6. So our a is 3, our b is -1, and our c is -2. A times C, 3 times negative 2 gives us negative 6. We've got to think what multiplies to create it, but what adds to create negative 1. So I know that 1 times negative 6 creates negative 6, but that's going to give me negative 5 when I add them. And then 2 times, so if you've noticed, I always just start with 1 and just think of the multiplication working my way up. 2 minus 3 is negative 1. Bingo, found it. I don't have to write any more. So now we're going to break up our b term with those numbers because we're undoing the multiplication. Okay, so remember, that stays the same, that stays the same. This is really the same problem. I'm just undoing that, okay? I'm going to factor by grouping. They both have an x, but I'm left with 3x plus 2. Now bring down the negative. You always bring down the symbol in between. And then I'm going to try to factor 3x minus 2. 3 and 2 have nothing in common. They don't have an x. The best I can do is 1. So if I pull a negative 1 out of 3x, I'm left with 3x. And if I pull a negative 1 out of 2, I'm left with positive 2. Now look here. It's the exact same thing. So that is my first factor. And the leftover is my second one. And I'm done. Okay, please email